Picture this. An ancient human is sitting at the edge of a riverbank staring at a rock. Not in the way you might stare at something you find aesthetically interesting or philosophically meaningful. In the focused, slightly vacant way of someone who has been staring at the same object for a very long time and whose thought process, from the outside, is completely opaque. There is no obvious outcome being produced, no food being prepared, no shelter being constructed, no predator being monitored. Just a person, a rock, and what appears to be a profoundly unproductive use of an afternoon. Except something is happening. Something that looks, from the outside, exactly like doing nothing but that is. From the inside, a form of cognitive processing that is going to produce an insight about the rock, about rocks like it, about what this type of rock does when struck at a particular angle against a different type of rock, about how the flake that results from that strike can be refined, about what that refined flake makes possible that was impossible before it. This is not a passive afternoon. This is the interior of a mind working on a problem that has no obvious solution yet, that requires holding multiple variables in working memory simultaneously, that requires the imagination of outcomes that do not yet exist in the physical world. The staring at the rock is the work. And from the outside, it looks exactly like the dumbest possible use of available daylight. This is the paradox at the center of today's topic. The habits, behaviors, and patterns that made ancient humans progressively smarter, that drove the cognitive evolution of the species toward the extraordinary capabilities that eventually produced language, art, complex technology, and the accumulated cultural knowledge that separates modern humans from every other animal that has ever existed. Looked from any outside observer without knowledge of the outcome, somewhere between pointless and actively counterproductive. They were habits that wasted time, that served no immediate survival function, that could get you killed if pursued at the wrong moment, and that produced results if they produced results at all across timelines that stretched well beyond the immediate calculation of daily survival. But they worked. And understanding why they worked, what the specific cognitive mechanisms were that turned apparently dumb ancient human habits into cumulative intelligence gains, is both scientifically fascinating and deeply relevant to how you think about productivity, creativity, and the relationship between doing nothing obvious and producing something significant. Start with the habit that looks the most immediately ridiculous and is the most consequential in the archaeological record: playing. Not hunting, not foraging, not building, not doing any of the things that obviously keep you alive. Playing. Chasing things for the satisfaction of chasing them. Throwing objects at targets without any specific material objective. Practicing movements in contexts where the practice itself produces no immediate return. Making and remaking things that already exist and do not need to be remade. Ancient human children played extensively, and this is not surprising. Play is widespread in young mammals and serves documented developmental functions including motor skill development, social skill practice, and the low-stakes rehearsal of behaviors that will eventually be deployed in high-stakes contexts. What is more interesting, and what the archaeological evidence suggests, is that ancient adults also engaged in what can only be described as play. The creation of objects and arrangements that served no practical function, the repetition of skilled activities in contexts where the repetition was not producing new practical output, the exploration of materials and techniques beyond what any specific task required. The cognitive function of adult play in ancient humans connects to the mechanism of neural pathway consolidation through repeated activation. When a behavior pattern is practiced beyond the minimum required for competent performance of a specific task, when the skill is practiced to the point of automaticity and then practiced further, the neural circuits underlying the behavior become more efficient, more reliable, and more available as computational resources for other processes. The toolmaker who has napped enough flint to produce functional spear points without conscious effort is not wasting their time napping additional flint beyond what the group's immediate needs require. They are freeing cognitive bandwidth. They are taking a process that previously required conscious attention and moving it into a level of neural automation that releases the attention previously devoted to it for other purposes. This is the paradox of practice as play in ancient cognitive development. The behavior that looks like an inefficient repetition of something already mastered is actually a cognitive efficiency upgrade that increases available processing capacity for novel problems. The ancient human who played at their skills? who practiced beyond necessity, who explored variations beyond what any specific outcome required, was building the automated neural substrate that made higher order thinking possible. You cannot think big thoughts about the structure of the world if all your thinking capacity is consumed by the mechanics of keeping yourself alive. Play and the automaticity it builds is what creates the cognitive surplus that innovation requires. The next habit that looks dumb from the outside and is transformative from the inside is talking about things that are not there. Storytelling. Not in the sense of entertaining people around the fire with an engaging narrative, though that happened and mattered. In the more fundamental sense of the cognitive operation itself, the construction of mental representations of absent objects, future events, past experiences, and entirely hypothetical scenarios, and the expression of those representations in communicable form. This is a cognitive capability that, when examined carefully, is deeply strange. Most animal cognition is present tense and concrete. It operates on what is here, now, perceptible. The remarkable and unusual thing about human cognition is its capacity to operate on what is not here, not now, not perceptible, on memories of the past, anticipations of the future, models of other minds, and entirely constructed hypothetical scenarios that have never existed anywhere except in the brain producing them. This capacity is called mental time travel, and it is one of the most distinctive features of human cognition. Ancient humans exercised this capacity constantly, in contexts that would have looked to a skeptical observer like idle conversation about nothing actionable. Discussing what happened 3 days ago when the hunt went wrong is not directly useful in the present moment. The prey was not caught, the food was not obtained, the moment has passed. But rehearsing what went wrong and why, and what could have been done differently, is the construction and refinement of a causal model of hunting failure that can be applied to prevent the same failure in the future. The idle discussion of past events is, cognitively, the building of predictive models from historical data. Similarly, discussing what might happen, the hypothetical future hunt, the possible alternative route, the what-if scenarios that ancient groups apparently spent significant social time exploring, looks like speculation without practical value. The future being discussed has not happened and may never happen, but the cognitive process of building detailed mental simulations of future events and evaluating those simulations for likely outcomes is exactly the process of forward planning. The capacity to anticipate problems before they occur and prepare solutions before they are needed. That is one of the most powerful and most distinctively human cognitive adaptations. The habit of talking about things that are not there was building, continuously and cumulatively, the mental simulation capabilities that eventually made it possible for ancient humans to plan migrations, coordinate large-scale hunts, manage seasonal resource cycles, and eventually design and execute projects whose completion lay months or years in the future. It started as stories around a fire. It ended as the cognitive architecture for civilization. Collecting things that have no obvious use deserves examination here, because it appears in the archaeological record earlier than many people expect and is more cognitively significant than its surface appearance suggests. Ancient humans collected ochre, shells, unusual stones, feathers, and other materials that served no obvious dietary or survival function, at sites that predate the period most people associate with symbolic and artistic behavior. These collections have puzzled archaeologists because they do not fit neatly into the survival-focused narrative of what ancient humans were doing with their time and energy. The cognitive significance of collection behavior is connected to the capacity for categorical thinking, the ability to identify objects as belonging to a class based on shared properties, rather than treating each object as unique and unrelated to others. Collecting red ochre requires identifying redness and ochreness as properties that make this stone similar to that stone in a way that is relevant to whatever the ochre is being collected for. Collecting shells of a specific type requires identifying the type-relevant properties across individual variation. Collection behavior is applied taxonomy, and taxonomy is one of the foundational cognitive operations underlying science, medicine, ecology, and virtually every other systematic domain of human knowledge. Ancient humans who collected things were practicing categorical perception, training their brains to identify and sort on the basis of properties rather than individual objects. This habit, which produced accumulations of colored rocks and shells that served no obvious survival function, was building the cognitive infrastructure for systematic classification of the natural world. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. The person who collected 50 pieces of red ochre because they found the redness interesting was, cognitively, doing something adjacent to what eventually became chemistry, medicine, and natural history. The collection was the symptom. The categorical perception it reflected and reinforced was the capability. Doing the same thing a slightly different way every time, which looks like inconsistency or carelessness, and is actually one of the most potent innovation mechanisms available, deserves specific attention because it is present throughout the ancient tool record in a way that reveals something important about how ancient cognitive development actually progressed. Ancient stone tool traditions show variation that, for a long time, was interpreted as evidence of imprecision. Ancient tool makers trying to replicate a standard form and failing to do so exactly. More careful analysis has revised this interpretation. The variation in ancient tool assemblages is often patterned in ways that suggest exploration rather than failed replication. Systematic variation around a central form, as if the maker is testing what happens when this parameter is changed, what the result is when the angle is slightly different, what the behavior of the stone is when the platform is prepared this way versus that way. This exploratory variation is the behavioral signature of curiosity-driven learning. The habit of not doing the same thing exactly the same way every time. Not because precision is impossible, but because the variation produces information. Each slightly different approach is a low-stakes experiment that returns data about the relationship between process and outcome, accumulated across thousands of individual tool-making sessions across many individuals across many generations. This exploratory variation is the mechanism by which technical knowledge advances beyond what any individual could discover through purely deliberate experimentation. The ancient toolmaker who varied their technique slightly, tried the angle differently, used the platform in a way that did not match what they had been shown, and noticed what resulted. This person was doing something that looks like imprecision and is actually empirical investigation. The scientific method, in its most fundamental form, is the systematic practice of this same basic operation. Ancient humans were running it informally, incompletely, and without any conceptual framework for what they were doing, but they were running it, and the progressive technical sophistication visible in the ancient tool record is the cumulative output. Watching other people carefully for extended periods without any obvious productive activity being simultaneously performed, this is another ancient habit that looks like a waste of time and is actually the primary mechanism by which social learning operates. Humans are extraordinary social learners. The capacity to acquire complex skills and knowledge through observation of others, without requiring the direct experience of trial and error, is one of the most powerful cognitive adaptations in the human repertoire, and one of the foundations of cumulative culture. But effective observational learning requires sustained, detailed attention to what the observed person is doing, not a brief glance that captures the general shape of the behavior, but the extended, focused observation that captures the specific details of technique, the sequence of steps, the handling of material, the decisions made at each choice point in the process. This kind of sustained observational attention applied to someone else making a tool, processing a hide, navigating a route, or managing a social situation looks from the outside like an ancient human standing around watching another ancient human do something. It is, cognitively, one of the most efficient learning mechanisms available. The ancient human who spent a morning watching an experienced elder nap flint, apparently contributing nothing to the group's productive activity for those hours, was acquiring technical knowledge at a rate and fidelity that independent trial and error learning could not approach. The apparent idleness was an investment in skill acquisition with a significant return, and the social norms that allowed this kind of extended observation that did not immediately redirect every group member to whatever appeared most urgently productive in the moment were themselves a form of cultural intelligence. Groups that allowed extended observational learning were groups whose average skill levels benefited from the capabilities of their most skilled members in ways that groups demanding constant, immediate productive contribution could not achieve. Making things more complicated than they need to be is a habit that looks like a failure of efficiency and produced, in the ancient context, some of the most significant cognitive advances in the archaeological record. The basic principle of parsimony, if a simple solution works, use it rather than the more complex one, is sensible engineering practice and bad innovation policy. Ancient humans who, presented with a functional tool, wondered whether adding a second element would improve it, whether hafting the stone point to a wooden shaft would extend its utility, whether attaching a handle to a cutting tool would improve control and reduce hand fatigue, whether combining materials that served different functions could create a composite that served a combined function better than either alone. We're doing something that looked like unnecessary elaboration of something already working. The stone flake cuts. Why make it more complicated? The answer is that the exploration of unnecessary complexity is the mechanism by which composite technology develops. And composite technology is one of the most significant signatures of advanced ancient human cognition in the archaeological record. Creating composite tools requires planning across multiple separate manufacturing processes, the management of multiple different materials with different properties, and the construction of a mental model of how these elements will function together before they are assembled. It requires holding a future state in mind and working backward to the steps required to produce it. This is the same cognitive operation that underlies every form of complex project planning in modern human life, and its ancient origins lie in the habit of making things more complicated than the immediate situation required. Getting lost on purpose, or at least not immediately returning from exploration when the exploration produced no immediate resource payoff, is an ancient habit whose cognitive yield is so significant that it deserves the most careful examination. The mapping of territory, the construction of detailed, accurate, retrievable spatial models of the landscape, is one of the most cognitively demanding and most practically valuable capabilities that ancient humans possessed. The quality of a group's territorial knowledge directly affected their ability to find food and water in normal conditions, to locate resources in crisis conditions, to navigate safely, and to exploit seasonal resource patterns that required being in the right place at the right time across an annual cycle. Building detailed territorial knowledge required exploration that, in the moment, produced no immediate return. Going further than necessary to reach a known resource, taking an unfamiliar route back from a successful hunt, spending time in areas of the territory that were not currently resource productive but whose properties in different seasons or conditions might prove relevant, all of this looks like inefficient use of time and energy in the moment and is, across the arc of a group's annual resource management, one of the most valuable cognitive investments available. The ancient human who wandered, who explored without a specific productive objective, who returned to camp with information rather than calories, was doing something that the group's immediate caloric accounting would record as a poor investment, and that the group's long-term adaptive capacity depended on. The information acquired through non-instrumental exploration, this valley has a spring that runs in dry seasons, this ridge offers visibility across the adjacent territory, this area floods in heavy rain and should be avoided in that season, is the kind of ecological knowledge that elders carried, that oral traditions encoded, and that was irreplaceable in the crisis conditions that eventually tested whether a group had it or not. The specific ancient habit of doing things together that could technically be done alone, eating communally when solitary eating would be more caloric efficient, making decisions through group discussion when individual decision-making would be faster, performing activities in social contexts when the activity requires no social coordination, is the last habit on this list, and arguably the one whose long-term cognitive consequences were the greatest. Human cognitive development is fundamentally social. The large human brain did not evolve primarily to solve environmental problems. It evolved primarily to navigate social complexity. The demands of tracking relationships, modeling other minds, managing coalitions, negotiating cooperation and competition within groups, and maintaining the social infrastructure that made collective action possible were, in the environments where human cognitive evolution occurred, the most cognitively demanding challenges that ancient humans faced. And those challenges were met across evolutionary time by progressive increases in social cognitive capability that produced, as a side effect, the general cognitive capacity that then got applied to tool making, environmental management, and everything else. The ancient human habit of doing things together, of making social context out of activities that did not require them, was building, continuously and cumulatively, the social cognitive infrastructure that is the foundation of human intelligence broadly. The conversation while processing hides that was not strictly necessary for hide processing was building social models, refining communication skills, practicing perspective taking, managing the emotional dynamics of proximity and shared task. The communal meal that was not strictly necessary for individual nutrition was practicing the resource sharing norms and the social bonds that made collective action possible in high stakes contexts. The dumbest looking ancient habits: sitting still and thinking, telling stories about things that had not happened yet, collecting rocks of a specific color, making tools unnecessarily complex, wandering without purpose, sitting with other people doing things you could do alone, were the habits that built the cognitive and social architecture that made everything else possible. They looked unproductive because their products were not objects or calories but capabilities. Ways of thinking, ways of learning, ways of relating, ways of knowing the world that accumulated across individuals and across generations in the same cumulative way that technical knowledge accumulated, each generation inheriting the cognitive and social capabilities built by the previous one and adding their own layer of development. The brain that eventually produced language, art, mathematics, navigation, medicine, and the entire accumulated edifice of human knowledge was not built by the habits that look smart from the outside. It was built by the habits that looked pointless, redundant, or distractingly elaborate, and that were, in fact, the specific cognitive exercises that the architecture of human intelligence required to develop to its full capability. The ancient human staring at the rock by the river was not wasting an afternoon. They were, in the specific and meaningful sense, doing the work.